Okay, an unknown compound has a molecular formula of C3H6O. It's definitely got a double bond because it's got the alkene, twice as many hydrogens as there are carbons. So the double bond is probably going to be a carbon-oxygen double bond, but it could be a carbon-carbon double bond. So it says it's got a strong sharp peak at 1700, which is the carbon-oxygen, the carbonyl. It can't be this one, the alkene double bond, because that's at 1620 to 1680. And it's got no other distinctive peaks, so it must just have a carbonyl. So the proton NMR has 3 peaks with this splitting, and the carbon has carbon NMR, so there's 3, each carbon has a different chemical environment. So it's either an aldehyde or a ketone, which means your carbonyl is either in the middle or on the end. If it's in the middle, then these CH3s are all in the same environment. Each of those, they're all equivalent hydrogens. They're all on a carbon with 2 other hydrogens on them, and they've all got the same neighbour. So there would be just one big peak worth 6 hydrogens, the area, and it's not split because there's no hydrogens on the neighbouring carbon. There's 2 peaks on the carbon NMR because there's these carbons and this one. If we look at this one, these 3 hydrogens here, there would be a peak that has an area worth 3 hydrogens, and it would be split into a triplet because it has 2 hydrogens, neighbouring hydrogens on the adjacent carbon. So the carbon next to it has got 2 hydrogens. So according to the n+1 rule, n is the number of hydrogens on the neighbouring adjacent carbon, and there's 2. So 2 plus 1, it'll be split into 3, and 3 is called a triplet. This one, in the Edrolo textbook, one of the questions, the answer was wrong. This is like a hydroxide ion. This oxygen shields this, so it doesn't split these. So this is only split by these. So it's got 3 hydrogens plus 1. It'll be split into 4 into a quartet. So these will be split into a quartet, and this one, because of this shielding it, it has no experience of the neighbours, so it's a singlet, just like an oxygen OH group. Okay. This is the one that I did last year, and because we didn't do mass spec, I just cut this down and called it the molecular formula. But if you're given the empirical formula, you'd need to look at the mass spec and see how big the actual formula is. So the empirical formula has got 5 carbons and 12 hydrogens, so it could be twice that, 10 and 24, but the largest peak on the mass spec is at 72, and if you add it up here, add up the size of this formula, you get it being 72. So the simplest formula and the actual formula are the same thing, and this is caused by that whole molecule having lost an electron and being positively charged moving through the mass spec. So we've got 5 carbons to play around with. We can put them all in a straight line. The ones on the end are this is a symmetrical molecule, so it's got the same on both sides. The ones on the end are in the same chemical environment because each of these hydrogens are attached to a carbon with 2 other hydrogens and has a CH2 as its neighbour. So these are in the same environment, these are in the same environment, and these ones are different. So you've got 3 hydrogen environments and 3 carbon environments. So it's not this. So we're looking for one with a single peak. If we take one off the end and put it on one of the ones in the middle. Doesn't matter if we put it on here or here, it'll be the same molecule. Then these, so it's branched, these CH3s are in the same environment as each other. So if you've got two CH3s attached to a carbon, then they're both equivalent to each other. So be careful when you do that to notice that. So any branching makes them the same. So they're both attached to a carbon which has got one hydrogen on it. So we've got 1, 2, 3, 4 chemical environments for hydrogen, and 1, 2, 3, 4 carbon environments. So it's not this one. So if we take another one off the end, so we've only got 3, and put it on the middle again, when you're making the branch, you can only take them off the end and put them on middle carbons. Then we've got a carbon in the middle surrounded by 4 CH3s. So all of these are in the same environment. And we've got 2 carbon environments. So this carbon here and these carbons. So you've got 3, 6, 9, 12. So you would have one peak that's not split because there's no hydrogens on this carbon. One peak worth 12. One peak area of 12.